Today we're going to learn about the law of sines. So far we've learned about sine, using that with opposite and hypotenuse in right triangles. But the law of sines is something that we can use for any triangle. So by matching up the angles and the opposite sides, we can say the sine of angle A over side A is equal to the sine of angle B over side B, which is also equal to the sine of angle C over side C. Those proportions work for any triangle. We can use law of sines if we are given an opposite angle side pair, like sine of A over A or sine of B over B, sine of C over C. We have to have one of those. And then we can find the other pieces as long as we have one other piece. It could be one other angle or one other side. In this case, we have one other angle. So they set it up as sine of 19, sine of A, over 16, because that's the opposite side, which would be side A, equals sine of 40 over the opposite side of x. To solve this, they showed a lot of steps here. We have solved proportions before, so the quicker way, instead of doing this and then cross multiplying and dividing, we can just do this all in kind of one big step. Sine 40 times 16, and then divide by the sine of 19. And we'll get the same answer. This will actually be more accurate if we do it all as one big step because we don't have rounding. So we need to do sine 40 and then times 16. And then if we want to use our previous answer, this calculator has a button that says A and S, so it uses our previous answer. And then we can divide by the sine of 19 to get 31.58. This had 31.56 because they rounded some things up here. Your calculator may be a little different if you want to use the answer button, or you can do it all in one go. Sine of 40 times 16, and then divided by the sine of 19. And we get the same answer just by putting it all in at once. But how about finding the other unknowns? So we found this side, and we have two angles on the other side. We are still missing angle B and side B. Well, angle B is easy since we already have two angles. We can just do 180 minus 40 minus 19, and that will give us 121 degrees for angle B. And to find side B, we can use this law of sines again now that we know angle B. So I can say the sine of 121 over B, that's this piece, and I want to just set that equal to either of the other ones. I would choose the one that we started with before because it doesn't have a rounded answer. So sine 19 over 16, but now I'm setting it equal to sine of 121 over B. Same process, we're going to multiply across and then divide up here. And when we do that, we should get 42.1. And then we've solved that triangle. So in the last unit, we only were able to solve right triangles. Law of sines is one way that we can solve for any triangle, not just right triangles. So in this triangle, I want to find my opposite set. So I have sine of 29 over 26. That is a pair. And then we have an angle. So sine 50 over the opposite side, we'll call that x. Again, I'm going to multiply sine 50 times 26 divided by the sine of 29. You guys put that in your calculator. We should get 41.1. But when it asks us to solve each triangle, that means we need to find all missing pieces, and we only found this missing piece. So again, we need to do kind of what we did over here. Find the other one by doing 180 minus 50 minus 29 to get the other angle to be 101 degrees. And I'm going to go ahead and just use this same proportion, but set it equal to sine 101 over, now this unknown, I'm going to call it y. So I'm going to ignore this piece right now because we already found that. Using this just because I already had it set up. I could set up a separate formula. In this case, we're going to do sine 101 times 26 divided by sine of 29. And that should give us 52.6. We can also use law of sines to find missing angles. So this time, instead of having a second angle, we have a second side. So this is set up as the sine of x over 36, and then we have our sine of 75 over 50. Solving it in a similar way, we would cross multiply, so 36 times the sine of 75, which is what they got here, and then divided by 50, which is what they did here. Okay, so we just kind of jump these steps by doing our cross multiplying. And last step, since we have sine of x equals something, we need to find the angle. And just like when we used sine before, whenever we find the angle, we have to use inverse sine. So we're going to use inverse sine of this, and it gives us 44. 36 times sine 75, and then divided by 50. There's where we got this decimal. And if I want to do inverse sine, this one I have to use my second function. And instead of having to type in this whole decimal or round it, to be the most accurate, we don't want to round the decimal. I want to use this in my calculator. So I'm going to go ahead and hit answer, and it plugs it in for me. Your calculators have that option as well. So 44.06 or 44.1, they had rounded it to 44 because they didn't use the whole decimal. So if you use your calculator properly, you will get a more accurate answer. So in these calculators, this one has that answer button right down here. This one you'll have to use the second function because it says it right here, ANS. So it'll be this button where it has a negative, but you have to use the second function first. Some of the other calculators you have, they're very similar. It's either already a button here or you have to use the second function, but that's where it is on the majority of calculators. And then it says, what about the other unknowns? So after I find this angle, we could find the third angle by subtracting from 180. 180 minus 75 minus, I'll go with what they have here, equals 61. So last piece, we need to find this side. Well, to find a side, we can do basically what we just did on the last couple examples. Sine 61 over y, and set that equal to the pair that we have here. When I put this in my calculator, we get y equals 45.3. Let's do one more example together. We start with our angle side pair. So sine 63 over 44 equals, I'm given another side, so we need to figure out what the angle opposite of that side is. In my calculator, we would do 40 times sine 63 divided by 44. And don't forget, after we do that, we have to use inverse sine to find the angle. So inverse sine of my previous answer gives me 54.1. So x equals 54.1. We need to finish solving the triangle. So now we know that x is 54.1. I'll label it degrees because it's the angle. We can subtract 180 minus 63 minus 54.1. So this angle is 62.9 degrees. And I'm going to go ahead and solve for this last side by doing sine 62.9 over y. And so I multiply sine 62.9 times 44 divided by sine of 63. I just ignore this piece right now. We're just looking at this as two separate proportions, and we get y equals 44. Let me round it up. You guys try the other examples and the back of the worksheet.